Welcome back to Cloud Computing and Big Data. We have reached our final lecture, lecture 16, where we therefore a little bit like reflecting on the course content. The epilogue will also show you a little bit the bigger picture here and there, what stays, what basically also are job descriptions, and where we find in these job descriptions some of the material you learn basically in this course. But as you know, before we go into the material of our lecture, let us have a review of our last lecture. And this was about a large topic, online social networking. It was actually lecture 15, not 14 this year, but it was about graph databases, how we basically have a data structure that can cope with all the uncertainties that you really have basically in this interesting data generation tools. And one of the ideas was to think about sometimes the volume is just exploding. Think about an influencer. There are many different users, but one user really has lots of videos. One user has lots of, likes, lots of relationships. The content is looked at. People like it. People share it. And with all the dynamics that you have in all of these different platforms, and don't think about the ranking here, it's much more important to understand that all these social media platforms in one way or another have a sort of structure which is much more like this, very unstructured, as we saw it in this lecture last time. Facebook, some people share their names, some people share only their phone numbers, some don't share phone numbers, but rather emails. The content is very different. Some are actually not just, using Facebook really. They're just inside to look at others, right? They don't share anything. They just do an account to look at others. I have seen that also. And some really using it heavily. As you also know from the last lecture, I told you we use it heavily also in research to show the taxpayers what we do with all the multi-millions we get in research. Hence, for us, it's also a sort of important tool to reach many people. And I think this reach is one of the success paradigms in the cloud computing part that you really see in that, because it scales again significantly to billions of users across all of these online social networking sites. And basically, if you then look at the relationships and considering basically little bit what we know from graph theory, the content and the people can be nodes, while the links were said like, okay, this is tagged in something. This is authored by this particular person. This person likes the content. The other one is sharing this content. All of these relationships with the contents and people is basically alluding to something we know from graph theory can be very nicely represented with graphs. Now, this is a big topic and should be entering the, let's say, curricula of a cloud course, not really, rather than a database course, right? So I think modern database courses should have something like graph databases, should have something like NoSQL, we also had discussed in one of the earlier lectures. However, just to give you a pointer on this, maybe for further studies, also the Tao database that we had the last time that I just really could, look at from 10,000 feet perspective. There's some information on Facebook engineering, which is now meta engineering, of course, but it's a very interesting idea of how you can manage databases where you have to think, and that's what we discussed also more in a geographical distribution sense, right? So the database, think about, needs to be also not only stored in one little data center. You think the size and also the fault tolerance, right? So what happens if one data center is suddenly out of service? We don't want to have Facebook stopping, right? For instance. Hence, there needs to be varieties how you basically have this database geographically also distributed working. And the most important factor for us, of course, as user perspective, it needs to be high performance, right? So if we see a like in 1 day or 2 days, that doesn't help us. If you share the content and it's actually shared among my network in 3 days, while the event is today, it doesn't help anyone. So the performance behind it is one of the most challenges, and also, of course, one of the most unique selling propositions of these elements, because then you think, with this, I can do many different things, and that's where also the revenues come from. Of course, we want to see ads. Let's say I'm interested in big data. I want to see maybe an ad on a big data event that has happened today, and not, when I load in the website, sorry, this was like 4 or 5 days ago. You should have joined, but too late. We didn't came along with the data processing for it. Hence, this ad business a bit also relies, of course, of accurate, up-to-date information. It relies also that it is basically very interactive. So you click on it, you have the information immediately. Although you maybe never have been really in contact with the event organizers of this particular event, you just know you're interested in big data, they are doing something with big data. Suddenly there's a connection when you click on it. And when you basically then like that page or basically, engage in the event, say I'm interested in the event, for instance, on Facebook, then that should be directly there. And then of course, people that giving this ads get some feedback immediately. So there's a customer, a potential customer, some would say a lead, right? That basically helps us then to maybe create more further revenues. So this fuels a little bit this free registrations that you often have, right? You would wonder why you can actually enroll in Facebook for free. You give a lot of content information they work with, and with this content information, there's lots of ad business in Facebook. Some of you also know the Google space we discussed the last time in lecture 15, where we discussed, of course, in your web pages, you have here the example of the big data web page, how this could be all interconnected. You put an ad basically somewhere in the Facebook area. The Facebook area links on a website. The website again has different Google AdSense elements, links back to Facebook with this particular part here on top. So it can be all interconnected. And with this, every click counts. And you get even revenues maybe for your website. And of course, you can imagine this same story a little bit continues in the YouTube space, another online social marketing platform, if you want, in this respect, when you want to have ads there, right? So many of you will know that don't have a YouTube premium account. Maybe the normal YouTube always has its ads. And this, of course, is fueling also then this kind of free registration or free upload even of YouTube lectures. I don't pay anything, right? I share all my lectures on YouTube. In a way I have to, because I'm also partly financed by many of the research projects, right? So this is something where the taxpayer should get some free, let's say, opportunities also to see the videos. On the other hand, I don't want to really pay for the uploads. So all the capacity, think about the many gigabytes I probably uploaded already in videos. I didn't pay anything. But what, of course, for YouTube is a benefit. They have content, lots of content that people may be interested in. And with this, the ad business is growing. But yeah, exciting topic, because it now gets really in the domain of there's lots of money. We had that before with customer relationship management and ERP systems. But this ad business is really huge. It also goes with a small overlap to the SEO, search engine optimization, that some of you know also there are trainings, bigger courses around that are all related then to also Google Ads or Google AdSense. Hence, I would refer you to these trainings if you're interested in marketing and cloud computing, or the more facets in online social networking. Interesting topic that will stay for us probably. But let us come now to the closing of the course, the epilogue, as we call it. It is rather an informal lecture, so normally I'm standing in class and have lots of reflections with you. I'm sorry that I cannot be physically today with you, but I'm definitely, with you in spirit of finishing now the course. Congratulations for that. The epilogue should be just reflect a little bit on different views on the course. So think about mindset. So what can we do? What we learn, job offers, and so on, right? So what could be next steps for you? What courses might be interesting from the skill set perspective? You have learned a lot of cloud computing, a lot of machine learning, deep learning. Maybe HPC is very close, right? We have also this, where you basically have lots of skills which are a bit overlapping with HPC already. HPC is a bit more technical. We will not be on this 10,000 feet cloud part. So if you're interested in a little bit more technical topics, how to program in parallel, HPC would be good for you. And then on the toolset, you learned a lot, right? Tools which are on different levels, from the infrastructure as a service level, platform as a service, and software as a service level. And then, of course, here and there, I try to inject with you hot topics like AI, machine learning, deep learning libraries. And if we would have a little bit of more time, we would go into the domain of one of my research projects, Trust LLM, that I have with one of my colleagues, Hafstein here, got from our Horizon project, where we talk about large language models, which is a hot domain in AI in general, but also for Iceland, as we have a low resource language. Hence, these are all topics where there are lots of jobs outside, right? So the tools that we teach here inside this course, you will see are in LinkedIn job offers, in Glassdoor job offers, and so on. Hence, the structure of this lecture will be not like one of the content lectures you have seen. We really go a little bit more dynamic here through the content, think about another perspective. So what are really the main themes you have basically looked at? And when you come now to, let's say, job interviews, when you come to job description, these are things to search for. Then, of course, some ideas of, some thesis topics that are available at our site if you're interested. Some small marketing from my perspective for our course coming in spring 2025. If you're interested, I think you have at least some of the topics already covered. What is a CPU, GPU, the things we did, and the basics really remain the same for HPC. We just tuned them a little bit more to parallel computing and other applications that we have seen. However, of course, machine learning, deep learning is also there a big topic. And finally, I just want to connect you to our eHPC community again. Many of you have been already participating in our workshops. The workshops are there to stay, and you will be invited for free, of course, to join us. You will see the announcement usually on the eHPC websites. That is very important for us because we want to grow a community here in Iceland. It is already growing with our, let's say, workshop starting from the first workshop we had several years ago. So feel free to also, if the course is finished, to join us in these events. Now, let's look a little bit on cloud computing from another perspective with all the topics we had and thinking about the course motivation that we said and what we promised you at the beginning. So I think many of you have now understood a little bit what it means to process elements in parallel, right? Master worker, having more workers doing parallel processing. Distributed computing. So we did all of that in some cloud somewhere else, right? Remote. So that is an important part. And you could do this conveniently with this, let's say, Jupyter notebooks, for instance, very nice material. If you think 20 years ago when I started this was not at all existing. We had just SSH connections, very, let's say, technical. So this has all matured to a level where now cloud computing emerged and is really integrated in our society, in our work, everywhere. So we had here and there, of course, some theories, and we had programming where we said, okay, in this course, we don't really do big programming steps, but at least you could understand a little bit how the application of this distributed cloud systems can be programmed. Think about OpenStack, also the different pieces or the platform as a service levels where we connect the different Lego pieces together that are already lying there. And that is a point of not programming big. You just rather connect different Lego bricks that are already and then create something bigger. Again, of course, relationships to high performance computing are natural, right? We talked about GPUs. We talked about GPUs in different generations that fuel deep learning today, applications which are also using cloud computing a lot, not only in Google Colab scale with one little GPU or TPU. There, of course, in high performance computing, we always look a little bit on the bigger scale. But the key technologies are still the same. We just interconnect them to making, let's say, the bigger picture or to have larger scales that we here and there already touched upon in the course. Also, Marcel for hyperparameter optimization gave you the hint that, of course, with more, let's say, resources, you can also have better performance in AI modeling. Then I try to interact here in the course also the latest advances as best as I could. We had this hyperparameter optimization lecture is new this year, so I changed a bit some of the topics. We dropped the lecture on streaming, although that's also an important part, but it's basically not anymore, let's say, the hottest topic. That's why rather deep learning, these elements, machine learning, AI, has become a major hype in Europe, for instance, particularly. We have seen the AI Act, which I encourage you to look at, for instance, coming with regulation on AI. We have seen the AI innovation package in Europe for SME startups, which really draws an emphasis of creating AI factories, right, which are specifically done to create AI models with all what you have and need already in the factories. All what you need is a good idea and then, do it. So these are topics which are going now a bit beyond the course and should basically enable you to look a little bit, in further topics where also maybe master thesis topics are there. And of course, which will in one way or another affect you, especially if you see on the European activities here in Iceland, but also, of course, similar things are happening in China, but also in the US and States. Then, of course, I hope you understand now many of these things. Parallel processing, distributed computing, we already talked about what it means to have a high performance cluster, right? So not anymore laptops or one GPU or workstation client under your desk. We always think at data centers, and next week and the week after, we have opportunities to go to the Borealis data centers. Luckily, they will give us some, let's say, timings when we go in, and I encourage you to join us there. Then you will really see the scale live a little bit when we talk about racks and a data center. So this is all important to understand the cloud, what it fuels it in the back end, right? You see just a website, you see a Jupyter notebook, but what's happening in the back is enormously. So I hope we could here and there also make the point of that. We will see many technology transformations to more and more of these clouds. And one of the reasons is the simplicity for users in this. More and more people can actually use these technologies, which have been very complicated perhaps in the past, but now it's getting easier and easier. And then there, of course, is hype topics, which we had also in the last lecture, online social networks. Graphs are on vogue. I talked to you earlier in many of the different courses, and students said, well, web pages is one thing, but social media, that's where you get information. And, you know, I don't Google anymore, I YouTube it. These are, let's say, elements which also fuel more and more, of course, the idea going away from this websites, which were basically manageable maybe in content, to a much more unstructured way, where also this graphic comes from. So we perhaps didn't see really clear here in the big data waves that are still in front of us. And with this comes also the idea of AI. If you think about now, a next topic for you, which might be quite interesting, is the old topic of generative AI, that there's a bit of warning in it, but of course also lots of opportunities. So creating information with AI, right? So far, AI has been much used for, let's say, understanding data that we have to look at patterns, classification, clustering, predictions based on previous data. But with generative AI, and you know some of that from ChatGPT, large language models, things we cannot go into the course, unfortunately, but would be interesting topics to study, because they fuel, again, of course, this cloud paradigm of having more content, more information, but on the same way, more processing is needed to digest basically all of these and create also this information. Hence, interesting student topics for your next steps if you come basically out of this course. Also there, I have to say, generative AI is extremely on vogue, not only in academics, also in industry. I was in the London Business Club and basically invited to talk about generative AI with huge investor companies that all think about these topics. And this is something which really also is an opportunity for you. You will basically have a job perhaps that is coming into the domain of these generative AIs. So let us look now a bit more, let's say, again, from the 10,000 feet perspective on the cloud computing course, the topics we try to integrate here that are there to stay a little bit. So that's the point of some of the university elements, right? We don't teach some hypes and then it will disappear. So the theory pillar, the parallel algorithms we have seen, right? We have seen Apache Spark, the idea of parallelization. This is there to stay. You remember divide and conquer. It's a principle going back decades, and this will not disappear. To solve a problem in a collaborative way, in parallel, will stay. Even people and humans do it. Then the whole idea of scalability, speed up. This is something, of course, growing data. You have to scale towards this. And this is also something which will stay with us. We have more and more data to digest. And by having more data, you're also interested in the analysis of it. And you don't want to do the analysis, let's say, over a whole week and then get the results week by week. What you want to do is having a speed up of this analysis. However you do it, and mostly you will do it probably with parallel algorithms, that means you have a speed up and maybe get it in a day instead of a week. So there needs to be technologies enabling this, which is then the next pillar. But we have seen also in the theory the fault measurements. So the uptime of a data center will remain. We are, of course, interested in storing our data maybe and then keeping it. I don't want to hear that my data is lost. I don't want to basically press in Facebook a like button and then want to hear, well, your like was lost, sorry, our data center is just in maintenance, right? So all the idea is fault measurements, the theory behind it, uptime. We did this just a little bit, but it's a very important factor of why this is all so much used today, because cloud computing is becoming more and more reliable. And this is fueled by partly theoretical aspects, really thinking about fault measurements and so on. Then data mining algorithms, so getting sense out of data in a way of looking the data, what it is right now. We have seen clustering. There are no classes of data already existing, but through measurements in the data, let's say the Euclidean distance that we had, for instance, in clustering algorithms, right, like k-means and so on, you can think about there could be classes emerging of data, and this gives us a bit more understanding. And see, also Shadi has shown you several algorithms, FP growth, a priori, which are a little bit, of course, let's say not really machine learning yet. And this brings us directly to the next topic. Statistical learning theory is something what also would be something you should look at next when you really want to dive into machine learning, deep learning. There's lots of theory behind it. So this course was a bit more practical as promised. And of course, you can use these tools partly also without having a deep understanding of statistical learning theory. The question is still, do you do it right? Right? What we could not really teach was basically validation, regularization aspects, the law of large numbers, why basically learning is just possible in a probabilistic sense, right? We call that PAAS learning. There are many aspects to it that you need a certain capacity in the learning model to learn from certain amounts of data. So hence we had some of this inherently, and deep learning here and there also changes some of the pictures in this because you need really lots amount of data for deep learning. Hence machine learning and shallow learning is there to stay. But these are important aspects that capture a lot of theoretical aspects under the hood, where also here I have to say, I have to refer, and what I did also in the course, you to a proper machine learning course to really use that then. However, if you go to the job interviews, you can still say you did machine learning and deep learning. You have a rough understanding how that works. You have used convolutional networks even, and so on. So coming more to the techniques. What techniques are there to stay? Economics of scale. I mean, I got an interesting comment also in YouTube in a way from one of the community, the larger community of, say, economics of scale. Still a question mark about this, becoming more costly using hypervisors, which are partly maybe also together jointly now with the challenge of energy a concern. But the still idea behind it of saying it's much better maybe to use these larger data centers than your little data center in one of the small SME in the cellar will remain still an advantage, right? To think about that you are basically an operator of an SME, you do lots of different things and then also have a small data center to care of. Plus the technology evolves ever more quicker. So the GPU generations, if you look, coming from Volta to Ampere, now from Ampere to Hopper cards, this is a technology evolution enormously getting quicker, but also provides you more powerful techniques. So with this, you want to be basically partly even cutting edge, because this might be even the niche market you go in with a certain product. You need this particular technology. Hence, economics of scale, although there are some critics, which is understandable, is of course there something to stay. The in-memory optimizations, what we've seen in Spark and so on, leveraging memory of a HPC system, of a cloud system, based off any processing capability that you have will be still very important, because as we have seen, memory is basically the most fastest we have, right? Apart maybe from the registers that we have maybe in the CPUs itself, but memory is also precious. We don't have the large scale memory yet. Yeah, we have basically, there's some homework to do in the computing, let's say, community to really get that better. We have large tape archives covering petabytes. We have lots of databases that can be stored on hard disks with many, many terabytes, no problem. But when it comes to memory, it's suddenly getting extremely expensive, especially if you think about no GPUs, HBM, right, which is basically fueling the power of a GPU. These are things where still capacity problems exist, and we have to do more there. However, the optimizations to use and leverage memory as best as you can, remember the difference of Hadoop and Spark, right? This will be there to stay as well. Then the techniques where we discussed, especially in the cloud, the concern that essentially we accumulate data day by day, right? Again, online social networking is just one example, right? So you have all the users registering more content every day. You have your own website for uploading maybe Aurora Borealis pictures, right? And videos. Give some credit to those people and also sell that via your website. Whatever you do, you accumulate data. In this respect, you have to think about at some point in time, this may be tough to really transport all of this data to a big HPC system, compute it there for machine learning, deep learning analysis, and then get it back. So the question relies to this kind of paradigms that we had also then fueling the MapReduce paradigm again from the techniques. So you don't want to maybe transfer all the data. You want to have smaller compute entities directly basically at the data itself, having then this MapReduce idea with data nodes, where you can have small MapReduce jobs here and there. And what you avoid with this is that you have big data to transfer, right? Which becomes infeasible over the network if you have now talking about petabytes. Then you basically are in the domain of saying, I basically rent a truck, I put it on hard disks in the truck, and I drive physically this truck to a computing center and compute it there. Because transferring many, many petabytes over the internet will not be the way. Hence, this was a technique, or is a technique domain, which always will be having a trade-off between these computing to data or data to compute philosophy. Then we have seen the private public hybrid cloud. So this is a technique there to stay, mostly because we have lots of sensitive data in the world. Think about your medical data. Do you trust a hospital these days with your data? Yes. Do you want them to upload everything to Amazon, MS Azure freely, maybe using it in free tutorials? No. So there's basically sensitive material, and you can go on through all the different sectors you would have. This is the next, car from Porsche. The design, everything is something which might be very closed, right? So they use maybe a private cloud. We had also examples seen in, somewhere from VW. There are different examples where you will always have some sensitive data that you maybe would rather compute in the private cloud. And then there are some other elements in a company where you say, well, that could be easily computed in a public cloud. They are just numbers. Of course, for some, it's sensitive still. Maybe for others, you would say, no, that is something we can put in the public cloud. It's still not open, right? The point is here that AWS, MS Azure, and Google Cloud, of course, have still security measures. But the trust in it is still something where people talk about, hence giving rise to this hybrid clouds, right? Where you combine both usually. If you're getting to a, let's say, bigger enterprise, I think many SMEs are usually still more or less using public options. And in some respect, then private would be then alluding to, create your own OpenStack system, maybe somewhere in a small server. And then when you really go big for data analysis or whatever it is, you can use the public clouds. Hence, there's also a technique there to stay. Then the whole idea of, you would say, RAID factors, replication, distributed file system. So this is a big bunch of techniques which have stood the test of time. Of course, you want to have your data replicated in case, one data center, is falling apart for whatever reason, or is not available. Then it's good to have replicated data somewhere else. A service can go ahead. Distributed file systems, the whole notion then of course doing this also in a distributed fashion, not only from rack to rack in one data center, but rather geographically distributed, and then have then also the systems in place to really work with this distributed file system. You have seen the Hadoop distributed file system, for instance, as one example, enabling it. And then finally, in the techniques, what we also brought across, and of course a couple of others, maybe what you put on this level, but if you look from 10,000 feet, these are really the ones that can be staying for a long time here. Infrastructure virtualization is one of them that will not disappear very quickly. So we have seen resource sharing is possible with virtualization. You abstract really from the physical hardware, enabling you then certain different elements. And here's also the area of the containers to mention, right, which are sort of very similar than virtualization. You just rather get rid of the operating system, if I may say so, from 10,000 feet perspective. But the whole idea of not using the physical hardware in the infrastructure alone, right, sort of bare metal, but putting a virtualization layer on top, it enables resource sharing and then, of course, many other elements of better load balancing and many things you have seen in the course already. Then paradigms is also alluding to some certain aspects of perhaps approaches also that they are there to stay, and perhaps for a very long time even, right? Maybe longer than the techniques. The idea that high throughput computing is giving us, again, divide and conquer. So you're interested in some computing, perhaps rather on high performance computing, rather on something which is throughput. So data, you want to analyze all what you have in the newspaper's archive. You want to make an index and see how many of those have been in sports, how many articles have been in politics. And this is nicely to be basically embarrassingly parallel, as we call, or nicely parallel. So you can actually analyze all these newspaper articles independent from each other, right? They have no relationship while you analyze. You're just counting, you do summary statistics, you maybe do some indexing where people were named in, and so on, but there's no really interactions. All what you're interested in is the result, and then the result will have this conquer step that we learned a bit of saying, okay, he says a summary statistics. Now, this is in contrast to the high performance computing we mentioned, basically every now and then, right? And of course, as I said, I will basically recommend you also to take the course in spring 2025 if you're interested in. This is something where we usually talk about an enormous interaction, right? So weather forecast, you're interested in every little step when you predict the weather. How's the weather in your, let's say, immediate surrounding in the neighborhood, and so on and so on. So there's lots of interconnecting happening while you compute the results. And this makes a difference, and it's a paradigm there to stay, and very different from high throughput computing, where you basically compute on your own and then are just interested in the end. Hence, this divide and conquer via MapReduce is another one of these paradigms which will stay and is closely connected to high throughput computing, but not fully, because in high throughput computing, we make also the point that we can go really geographically distributed massively, right, without having any interconnections. While in high performance computing, this is essentially sort of a limit. You have to stay in a data center really to enable it, because you have very specific interconnect. You will learn this in the course high performance computing, InfiniBand and so on. So, and also these connections are usually very insecure. So high performance computing is rather something for the, let's say, data center in itself, while high throughput computing can be enabled by connecting many different data centers together. Then the 3 layers, and from the course also people have invented more layers, DB as a service and whatever as a service. And this is not something talking against it. I think there's some marketing branch also that would say it's good to have this IAAS or PAAS and SAAS, but also inventing new ones might be also something which is a good way of making your product known, right? Because infrastructure, platform, and software as a service, all these 3 levels you learned in the course are also there basically to stay and quite commonly adopted in all the different hyperscalers. You remember our AWS services, Google Cloud Platform, or MS Azure, but some of them, basically have some unique selling propositions on all of these different levels. And these levels basically will be there to stay. The infrastructure as a service level, very, let's say, close to the hardware, maybe having the virtualization as a common paradigm there, having already prepared images to use the infrastructure, as we have seen with AMI, for instance, with deep learning. Then platform as a service is Lego bricks analogy, right? So that there is already some tools, services around, but it's not something where I just swipe the credit card and use it. So me as a developer would want to use a platform. So this is why basically this PAAS level will be also there to stay. So people want to use a cloud for developments. They just not want to use it all the time, like we would rather do in the SaaS offerings, right, that we use. Hence, the whole idea of supporting developers by not creating, let's say, software components from scratch, but rather use those components which are already there, tune them, configure them, set up them together like Lego bricks, and then create a bigger Lego castle, as I may say. That's the point in the platform as a service. And that's what many organizations need, and still have the maintenance of the components itself covered by the cloud, the versioning, control, all of what you know from software engineering is quite challenging. Of course, there's one thing to say when I say, of course, this is all nice. Think about swiping still the credit card also for this platform, Lego bricks. Lego is becoming, sometimes quite costly. So in this sense, be warned also as a SME, just jumping on this track. Of course, you have to put somehow the payments for all the different services, SageMaker in practice, right? They give you lots of time in the beginning, but if you operate your enterprise over 5 years, then you will see suddenly these free hours are gone, and then you have to pay. And if you pay, you want to have cutting edge infrastructure. And again, the topic comes down to the point that, costs can accumulate. That I was also showing you by running the HD Insight cluster just for a couple of weeks for our assignment, because this was already getting to quite some hundreds of euros. And of course, an SME and, others have to incorporate that in your price scheme. And that's really the other perspective I wanted to give you, and reflect on the topics that we not just teach here university courses and say, these are interesting things I can Google around and give you some material. These are hopefully topics you can use. If you want to know more, there are some books, but these days I would say the books, yes, what should I say? There's lots of information out there. Let's put it this way. And I would almost take your own quote, as one of the students will say, I YouTube rather, right? So there's lots of YouTube elements what I can recommend you with excellent people teaching machine learning. Andre Ng, for instance, he is quite hard to understand sometimes, maybe, but he has good lectures, and there are many different lectures for machine learning and so on around. There are many different lectures on cloud computing as well. Be warned, of course, some of them from the cloud computing perspective might be very much alluding to one of the vendors, one of the hyperscalers. So remember the porting, right, and not having a vendor lock. But still, I think lots of information is out there to read and look at. And Datanami, HPC Wire might be other websites where you also get interesting inspirations from. Of course, if you want to be closer here in Iceland, I have lots of company contacts to cloud providers, data centers. We do lots of machine learning and research papers. So, you have my webpage, but also, again, as you were saying to me as students, web pages are, well, not so interesting anymore. Hence, I'm also basically on all the different platforms. If you want to further connect, I would be happy about it. Also, think about the different YouTube videos. Each course here is a little bit different. Hence, I don't use old recordings, right? As you remember, I always do fresh recordings because there's always updates. There's always a small thing which is new. And for instance, we dropped the streaming. Maybe if you're interested in streaming, looking at 2022 lectures might be relevant. If you're interested in high performance computing, not sure if you want to take the course in spring 2025, you can look at our course on YouTube in 2024, maybe skipping, some lectures, but looking roughly through the material. And then, of course, you get some inspiration if that course would be something for you. We do this year a special. We do next year a special. This year we did also, of course, a special on CFD. That is because some industry partners want to know and also learn more about it. And also for us here in Iceland, I think there are many CFD options where you can work. Iceland is a partner where we look at, for instance, with vertical wind access and so on. There are lots of opportunities. Hence, YouTube and all of that would be important. I promised you some job reviews, and what I usually would do if I would be in class with you, we would go to Glassdoor, we would go to LinkedIn jobs. These days, I have to say, in the last couple of years, really LinkedIn, and I'm not paid by LinkedIn, means that there's lots of opportunities. So firstly, I would encourage everyone who want to pursue a professional career to enlist in LinkedIn, but also the jobs part in it is getting more interesting. You get recommendations. You see here how it works when you search for AI. You're getting cutting edge information. A data scientist wanted for large language models. So that is the generative AI. I would encourage you to look in more. Also, if you're interested in this language part, here we have good, excellent professors here at the University of Iceland. Hafstein Einarsson is one of them that teach this topic, has basically different courses and different facets on it. We have together a really great Trust LM research project with topics for your master's thesis, PhD thesis, even if you're interested. So, but coming back to the job, even here in Iceland, I mean, basically since COVID, more and more things are remote, right? So this is something where you will find jobs, as you see here in the European Economic Area, remote, where you maybe even can be an AWS cloud specialist sitting in Iceland, but working somewhere else. And this is a vision of Europe that, of course, we basically embarking on with the European Union, with all of these projects and initiatives we have, that basically your location getting more and more independent of your job. But here's also some things in Iceland. You see here the consulting firm that is looking for large language model specialist. Basically, this would be one example with topics that you learned in the course directly applicable that you would have. You see here, for instance, in the one from AWS Cloud, no wonder you see cloud topics, cloud infrastructures, and so on and so on. Here, you should be a cybersecurity professional. Another, let's say, emphasis here in the University of Iceland. The proposal I submitted a couple of days ago was basically now the cybersecurity oriented one, where HPC clouds and so on play enormous roles today as well. We have here Tom Welch, that is one of the guys in our division that knows much more than I about that particular part. So if you're interested in cybersecurity, I would also basically would recommend you to take courses under that umbrella with Tom and others that teach, ethical hacking and all of these interesting courses that have all one facet of hacking cloud systems, right? So, and this is all interconnected, although it's of course more on the technical scheme underneath. And that's where perhaps also lots of jobs are there if you want to be, in this area. Just one highlight here, the OpenStack, as I told you, is enormously growing. So many people using it. You see here one example again, when I put in here just on LinkedIn jobs OpenStack in the capital area of Reykjavik. You have here all what you know from the cloud course, knowledge-driven cloud computing concepts, technologies. You have learned a lot there. Automation we did here and there as well. And then having a thorough understanding of modern infrastructure, OpenStack, or even Kubernetes, we teached a bit. If I would have a bit more time, we would get even more in details of kubelets, Kubernetes, the JC cloud, the infrastructures behind it that we have in Jülich there is serving also the Jupyter JC, and all of that is directly related to all of these technologies. Hence, you are a little bit at least familiar with the challenges of this large-scale multi-cloud operations, right? So hence, these job offers, if you now compare what you had in the course, should enable you to have a very good, let's say, chance to get some of these jobs at least. And remember also what I told also you at the beginning, you can always contact me, right? So for recommendation letters where I will say you have been part of my course and so on. Many students using that. So especially if you go abroad, then let me know. We can, of course, have always a recommendation letter for you. Then coming a little bit, perhaps a bit selfish, but we always want to have, of course, good students for our master and PhD thesis topics. So hence, we have lots of research projects. Many of you will know that because it was one of the reasons why I couldn't stay in front of class. But that enables money and lots of positions, master positions, PhD positions every now and then. So hence, if you're interested in these topics, talk to us, right? Maybe not myself has a PhD position, but someone of my colleagues or my deputy in the research group, Gabriel Caballero, has maybe a job right now in Jülich, for example, working with ESA. And so basically we are very well connected, and we can, always use people that have an interest in this. It's a very exciting field. I'm living in this for 20 years. My whole career is based on it. And I can say it's a very nice community that you see again here, being in Atlanta at the Supercomputing Conference. Friends, colleagues, experts I know since 20 years, and some of them are actually in the field for 40 years, right? So I'm a youngster in that, right? So you see people with badges, 35 years of supercomputing, while I get a badge of 20 years, right? So still, this is a lot if you focus and if you be part in this community. So that's why here a little bit the kind of idea. If you're interested, stay with us connected, right? Especially if you're in Iceland, we will have this eHPC workshops. You have been partly, some of you at least taking part in, then become maybe more involved with some of our simulation and data labs, right? We have a very strong remote sensing one, but you have seen on our eHPC website, we have also different labs with different specialities. Sound engineering is something what acoustics, people are also interested in with Runa and so on. So stay with us connected, be part of the community. And as you have seen in the eHPC workshops, many SMEs presenting there, industries participating, NetApp and whatever. So basically, the data centers are represented, the technology transfer offices are there with Oetna, enabling also maybe startups and giving you links to this. So it's a community that I would recommend to you if you have interest, especially in this field, right? But you see also that I can say HPC and cloud computing by now also is active in almost all fields, right? Everybody needs computing, storage, and especially now with AI also requiring HPC and cloud, you're basically at the position that we can also create different simulation data labs in almost all areas of science and engineering. That doesn't also mean that we are always the experts, as you know, basically for natural language processing and the lab, I would always refer for the language modeling itself to Hafstein, but of course also he needs large computing power in the cloud or HPC, where then we as HPC and cloud experts come in. We have a very nice community. My research group is now around 15 people. You see, we have also regular dinners, a bit more social aspects, right, which are going beyond the eHPC workshops, for instance. It was getting a bit slow in the COVID times, not now we're keeping up with this. Midterm evaluation dinners and so on. Just to show you a little bit what's coming up in 2025. There's a complementary high performance computing course. I had discussed this already also during the course a lot. People were asking me, I remember at the beginning, what is the message passing interface? So what we do there is much more elements like here you see how would maybe, smoke propagate alongside a tube. We will basically looking more in what would be really climate situation or Earth system modeling here of crunching up, let's say, space on the Earth to understand the groundwater modeling in different pieces, and then would have lots of interactions of understanding the water flow. This is one of the examples, again, not high throughput computing is helping here. We need high performance computing, interactions of water flow. If every second we simulate basically this water flow. The same is true for the stretch or basically the stress really on the materials that you see when the car crashes, right? 1 centimeter on the left side is affecting the right centimeter next to it. So hence there's lots of interactions on every millisecond when you have a car crash, and this sets it apart a bit from what we learned in cloud computing. And also I have to say it's a bit more technical. The programming is a little bit more in this course. MPI, we will program in parallel. We will look more at source code as such, not just Python scripts. Still, it's not a software engineering or software development course, so we will use many of the existing elements already. But still, I want to make the message that it's a bit more looking on the technical scheme, however, also fueled with applications, right? And as I said, we have a couple of these different domain-specific science and engineering disciplines, but we will also look a little bit into a special we call computational fluid dynamics, where we then looking much more on, fluid flow, airflow, and so on. But you see in basically, if you want, a 2024 course is online in YouTube, and you can have an inspiration if that course is something for you. Finally, some acknowledgements. My group is standing behind me significantly. Many of the students, many of the materials you have seen, Marcel Ach with a lecture. are basically helping me to keep up to date with lots of these different elements. Also, my recent graduates, PhD students, Shadi and Rocco, which are now postdocs, are here to mention. And also Dr. Gabriel Cavallaro is not anymore just a doctor, he is a professor now. So basically also at the University of Iceland and at the Uli Supercomputing Center at the same time. Hence you see a little bit nice how also this research group evolve basically with their degrees into, let's say, into really experts in the field, right? Where you would say Shadi here, you see him here at a medical hospital, for instance, with me, but also Rocco, Gabriel as remote sensing experts. So you will more specialize, although your route is somewhere a little bit partly also in HPC and clouds, but a specialization will also be possible. And then, you know, maybe you stay in academics, maybe you go to business, but it would be the same way. So of course, this is also true for other students I don't mention here. Hence, once again, also to our collaborations, a little bit of acknowledgements, thanks to the Borealis Data Center for giving us a tour next week. And the next ones, we have done this already in 2022, and I think the students liked it very much. So in this sense, stay connected again, think about the events which will come here in our eHPC workshops, and to give you a little bit of a history and the community impact really of what we do in HPC and clouds is this video going back 25 years, where you can see that high performance computing and cloud computing, perhaps later than it was not there in the 80s, had a big influence really what happened in computing. So in a way, that's where the name comes from, right? Formula One of computing, always at the cutting edge, the front. Is of course exciting, and that's why I want to recommend you to look the video. You see a little bit the successful history. And when you now look at the Nobel Prizes just recently and so on, this is of course something fueled with AlphaFolds, for instance, and deep learning is another example, fueled by computing underneath. Thanks for joining the course, everyone. And I would like also take now the opportunity to go beyond the course. I think the YouTube community was enormously active. I got very good comments. Thank you very much for that as well. And see you next time, hopefully with other courses or maybe even in person at some conferences like the supercomputing. Talk to you next time.